All right, so first off, what you're going to want to do in your notebook is put down this original problem, or these original problems. Both problems come from objective 22.2a. 22.2a. It becomes a 0 today. So let's go through this. It says to solve the equation by completing the square. And that's exactly how we're going to go about doing this, is to solve the equation by completing the square. So, to do this, you'll notice that when we have these problems, first off, we're solving. Okay, we're solving, we're not just factoring. Okay, in objective 21, or module 21, we did a lot of factoring, not as much solving. Much of objective or module 22 has to do with just primarily solving, not just factoring. What's different about 22.2 versus 22.1 is that you're going to come across some problems where you're not able to go directly to just taking the square root of both sides and then you get your answers, or your two answers. So you have to do something different. What you have to do is consider what you're going to do to this side and this side to make the left side factorable. To make it factorable. And we're actually going to be using a square to make this happen. We're going to go to our box. And we're going to consider just the left side. Okay, just the left side. X squared, we'll put at the top left-hand corner. But the thing is, we don't have a number to put at the bottom right. We don't have anything there. So this is what we do to come up with these numbers. Remember that when it comes to our little puzzle of sorts, we have to multiply two things to get to something, but again, we don't have the x squared and that something to come up with this number. But I do have what it should be adding to. What's considered the middle term here is the 8x. So 8x goes right there. Now it says in the problem to complete the square. It implies that our box is not a rectangle, but it is in fact a square. A little bit about squares. We know that they have equal sides, right? All sides are equal when it comes to a square. So what's nice about that is that all I need to do to consider what's going to add to 8x is to know that those two things are going to be exactly the same. What are two numbers that if I add together would give me 8 to the same number? Yes, 4. So we put down 4x and 4x. Now this helps me to figure out the rest of this puzzle here. Because now I know that this must be 4x and 4x. And although this is 16x squared, I'm kind of backing up here now. I know that this 16x squared is the multiplication of x squared and this number. So now I know this is 16. I know the 4x and the 4x, so that's 4x here and 4x there. Now what I'm going to do is I'm going to take what's called the greatest common factor. And now I'm just doing this all working backwards. And actually, before I do that, I'm going to take a look at this 16. The 16 isn't a part of the problem on the left side, is it? So what I do is I add 16 to both sides. I'm going to add 16 to the left side and then add 16 to the 33. So that changes things up a little bit to x squared plus 8x plus 16 equals now 33 plus 16, that's 49. And now I'll finish the factoring. So now I know x times x is x squared. X times 4 is 4x. And again, x times 4 is 4x. So that left-hand side can be factored to x plus 4 times x plus 4 equals 49. But x plus 4 times x plus 4, it's the same thing as x plus 4 quantity squared. Now if I'm told to solve this problem, I solve it a lot like I would have done in 22.1b. 22.1b. Now this problem is like that, where I took the square root of both sides. What is the square root of 49, by the way?
7.
Yeah, that one actually turns out to be a nice number. The next problem, it's not going to be so nice. Okay, the square root of 49 is, you're right, 7. But I'm going to separate it to two different problems because remember when you take the square root of both sides that you have positive 7 and a negative 7. So it's x plus 4 equals positive 7 and x plus 4 equals negative 7. And then you solve by subtracting 4, we get x equals 3. One answer. Subtract 4, x equals negative 11. Notice that my answer is not just positive and negative. It's not positive 3 and negative 3. That doesn't happen all the time. Okay, so don't think that that does. That's the final answer. Notice that this really isn't all that different than what we've been doing before. It's kind of putting a lot of things together. We're still working with the box. We're still working from the inside out. We're using what we learned in 22.1. Let's take a look at the next problem. Next problem here. Same logic. It says to solve by completing the square. So that's exactly what we'll do. So we're going to put our box together. Notice that it started off with x squared minus 6 equals 8. We have the number on the other side. That's going to happen with the majority of these problems at 22.2. You put the number on the other side. Okay, now what we're going to do is go to our box. The x squared gets put right here. Nothing gets put on the bottom right yet. Got to think of two numbers that will multiply to something, two numbers that will add to something. The only piece that I do know is the part that they add to. That's negative 6x. Now notice that it's a negative, and that's important. Negative 6x. And again, because it's a box, that's a square. What two numbers that are the same would add to negative 6x?
8.
Negative 3x and negative 3x. Right. Negative 3x, negative 3x. So those are the two numbers or terms. Negative 3x, negative 3x. And those two numbers multiply to give you 9x squared. Because of that, I know that this number is 9. And now I know what I'm going to add to both sides of my equal sign. I'm going to add 9 here and add 9 here. So changing our equation up a little bit, x squared minus 6x plus 9 equals 8 plus 9, which we know is 17. Now I'll go back and fill out the rest of my box here. I know this is supposed to be negative 3x. This is supposed to be negative 3x. And I know that the greatest common factor, or the biggest amount I can divide the top row by, is x. Then x times x is x squared. Yep, negative 3 here, negative 3. here. So then I have x minus 3 times x minus 3 equals 17. X minus 3 quantity squared then equals 17. And much like the last one, I'll take the square root of both sides. Here, can we take the square root of 17 and get a nice number? No. Okay, so then in this case, what I'm going to do is separate it to two different problems. One where I have x minus 3 equals positive square root of 17, and one where I have negative square root 17. Last step, I'm trying to get x alone. We add 3 to both sides. X equals 3 plus square root 17. You could have also put it after the root 17. It doesn't matter which way you write it, as long as your radical doesn't go all the way across the 3. Most people like to put the 3 first, so that they don't think the square root goes all the way across. So we have two different final answers for that last problem. 3 plus root 17, 3 minus square root 17. These are tough problems. They're not easy. They take time. If you have questions, you need help, just call me over. One thing's for sure, if you didn't write any of this down, then it will be a struggle. Okay? It will be a struggle if you wrote none of this down.